Okay, class, we're about to start section 2.1, the addition property of equality. Objective 1, identify linear equations in one variable. A linear equation in one variable is an equation that can be written in the form ax plus b equals c. We're going to list examples of linear equations in one variable. We can have 3x plus 9 equals 7. We can have negative 15x is equal to 35, and we can have x is equal to 2.5. These are just but a few examples of linear equations in one variable. Now we have here, list examples that are not linear equations in one variable. We can have 3x squared plus 7 equals 9. We can have negative 15 over x equals 35. And we can also have the absolute value of x equals 2.5. We solve an equation by finding all of its solutions. The goal in solving a linear equation is to get the variable by itself on one side and the number by itself on the other side. Now we can look at some examples. If I have x equals 7, y equals negative 8, x equals 1/2, w is equal to 2.5, and so on. It says objective 2, use the addition property of equality to solve equations. The method for solving a linear equation is to follow one of the most basic laws of algebra. Whatever you do to one side of an equation, you must do to the other side. Addition property of equality. If a and b are expressions and c is a number, then the equation a equals b and a plus c equals b plus c are equivalent. That is, we can add to each side of an equation without changing the solution. This also works for subtraction, even though it's not listed here, but this equation here will also work for subtraction. So we have example 1 solved. We have x plus 8 is equal to 2. Remember, we want to get this variable by itself. So we need to get rid of this 8 that's added to the x. And we get rid of that by subtracting 8 on both sides. Because we take the opposite of this plus 8. That leaves us x. We bring down our equal sign because 8 minus 8 is 0. So we'll just have x on the left side. And then on the right side of the equal sign, 2 minus 8 is a negative 6. So that takes care of A. Now we look here at B. We have 4 equals n minus 7. We're still trying to get this variable by itself. So we notice that we have a minus 7 with the n. So we would add 7 on both sides of the equal sign. So you have 4 plus 7 is 11 equals. We'll bring down our n, and a minus 7 plus 7 is 0. So this is our final answer. Now, we scroll down to the next page. We have example 1 solved. We have C, x minus 0.24 is equal to a negative 5.18. So we would add 0.24 and we would have x, a minus 0.24 plus 0.24 is 0. And that equals 2. Now we have to subtract these values here. What I would suggest is this here. Since both of them have different signs, I will go off to the side here and take 5.18 minus 0.24. We know we're going to subtract, so let's just do traditional subtraction. 8 minus 4 is 4. We can now subtract 2 from 1, so we'll borrow 1 from the 5. That'll be 4. And this 1 here will become 11. 11 minus 2 is 9. Bring down your decimal. And 4 minus 0 is 4. So we know our final answer will be a form of 4.94. Now to determine its sign, we look at these two numbers here. and we think about the absolute value. The absolute value of a negative 5.18 is a positive 5.18. And the absolute value of 0.24 is 0.24. We know 5.18 is larger, so we will write its sign as well. So our final answer here is a negative 4.94. Now we come to D. We need to get x by itself. So we will subtract 1/3 on both sides of the equal sign. Now we will have x is equal to, this will be a negative 3/4 minus 1/3. Now recall, in chapter 1, we found a common denominator here. We know if we go off to the side, the prime factorization of 4 is 2 times 2, and 3 is already prime. So we know our prime factorization that will give us our common denominator will be 2 times 2 times 3. So our common denominator is 12. Now we have to find our numerator. So we ask ourselves, 4 times what is 12? We know 4 times 3 is 12. So we will multiply this numerator and denominator by 3. 3 times 3 is 9. So this will be a negative 9/12. Now this 1/3, we ask ourselves 3 times what is 12? And we know that's 4. So we'll multiply our numerator and denominator by 4. And we have a minus 4/12. So our final answer here is x equals a negative 13/12. Now we scroll down here. Now this is more of a lengthy problem than the others. We're trying to get y by itself. But over here on your left side and your right side, we have terms that we can combine. So let's combine the like terms first. 8y minus 7y, we know would just give us y. 7 minus 10 will give us a minus 3. And that equals to 6 plus 4 is 10. Now, again, we want to get y by itself. And so we have a minus 3 here. So we will add 3 on both sides of the equal sign. So we'll have y, and a minus 3 plus 3 is 0. So we'll bring down our equal sign, and 10 plus 3 is 13. So it's y equals 13. Now we go here to f. We have 4x plus 2 equals. We have to multiply this 3 by this parenthesis here. We have to do the distributive property. So we know we would take 3 times x, which gave us 3x, and we would take this 3 and multiply it by minus 6, which would give us minus 18, plus 8. Now we try and combine like terms. We only have like terms on the right side. We'll bring down our 3x, and a minus 18 plus 8 will give us a minus 10. Now, we need to get all the x's on one side and all the numbers on the other. So I'm going to choose to move the x to the left side. We could move it to the right, but I'm choosing to move it to the left. So I'm going to subtract 3x on both sides. 4x minus 3x is x plus 2 is equal to 3x minus 3x is 0, and 0 minus 10 will leave you a negative 10. Now, we still do not have the variable by itself, so we're going to have to subtract 2 on both sides now, as we would take the opposite of a plus 2. So we will have x, 2 minus 2 is 0, and it equals to a negative 10 minus 2 will give us a negative 12. Now we look here at objective 3. It says solve applied problems using formulas. Example 2. There's a relationship between the number of words in a child's vocabulary, V, and the child's age, A, in months. For the ages between 15 and 50 months inclusive, this relationship can be modeled by the formula V plus 90 equals 60 times A. Use the formula to find the number of words in a child's vocabulary at the age of 24 months. Okay, so first of all, it says there's a relationship between the number of words in a child's vocabulary, V. So we're trying to find V. So we'll write V plus 900 is equal to 60. And then we have to find out what A is. A is the child's age. So the child's age here is 24 months. So we'll just put 24. So now we could go off to the side here. We know on the left side we will have V plus 900. But we'll go off to the side and multiply 60 times 24. 4 times 0 is 0. 4 times 6 is 240. Put our 0 here. 2 times 0 is 0. 2 times 6 is 12. So we add. We have 0, 4, 4, and 1. So this will give us 1,440. Now, we have to subtract 900 on both sides. So we will have V, 900 minus 900 is 0, and that equals 1,440 minus 900. 0 minus 0 is 0. 4 minus 0 is 4. We cannot subtract 9 from 4, so this 1 becomes a 0, and this 4 becomes 14. 14 minus 9 is 5. So it says use the formula to find the number of words in the child's vocabulary at the age of 24 months. So we could put at 24 months, a child's vocabulary should be about 540 words. And as a matter of fact, let's take the word about out. It would be 540 words, because this is an exact answer. But we know in the real world, some children's vocabulary will have more than 540 words. Another child's vocabulary may have, less than 540 words. But since we have an exact answer here, we'll leave it that the vocabulary should be 540 words. And that is it.